Okay, so I'm just going to quickly recap what we did before break, and then we'll build on that and talk about end behavior. So before vacation, we learned about intervals of a polynomial. So these are examples of polynomial graphs, those two, this one. A polynomial graph is positive when it's above the x-axis. So this green is all positive because it's above. It's negative when it's below. And I think we discovered this in the Kahoot on that last day before vacation, that a lot of you struggled with the notation. Like you kept interpreting this as ordered pairs, but this interval notation, this is like from -2 to -1. So remember, like from here to here, it's positive. So from -2 to -1, it's positive. So that's how you would write it. From 1 to positive infinity, it's positive. So that's how you would write that. So that's what the interval was. It's, you use the x value. So it's positive when it's above, it's negative when it's below. So all this pink is negative. So from -infinity to -2, it's below the x-axis. And then from -1 to 1, it's below the x-axis. Then we talked about increasing and decreasing. A graph is increasing when you're looking at it from left to right and it's going up like a positive slope. So the green was increasing. This is increasing. This is increasing. Again, to identify increasing intervals, you use the x value and you determine, like, see, the first increasing was from 1 to 3. So from 1 to 3, it's going up. From 4 to positive infinity, it's going up. And then decreasing is when it's going down. So we will recap this. We'll not recap it, but we will use it at the end of today's lesson. Then we talked about relative maximums and minimums, or the turning points in a graph. Anytime it switches directions, that's a maximum or minimum. So like this one's a minimum because in this vicinity, it's a low point. This one's a maximum because it's a high point in this area. And this is a minimum because it's a low point in that area. When you're doing maximums, minimums, those you identify with ordered pairs. So these are not intervals here. These are ordered pairs. So that's what we did before vacation. What we're going to talk about now is more about the graphs of polynomials, except now we're going to talk about something called end behavior. So let's talk about what end behavior is first. And like I said, when I first start talking about end behavior, it can be a little confusing. So please, if you have a clarifying question, just ask. Usually once we do it a little bit, it gets pretty easy. So basically what end behavior is, it pretty much just describes what's happening at the ends of the graph. So by the ends of the graph, I mean like where the arrows are. So here and here. Pretty much what we do is we think about, like, as we move to the right, where is the graph? Is it pointing up or down? As we move to the left, is it pointing up or down? So as we move to the right, this one's pointing up. As we move to the left, it's pointing down. However, it's not as easy as just left, right, up, or down. There is some special notation that we use. The notation that we use involves infinity and negative infinity. So just for the sake of answering these questions, I'm going to label the parts of this graph. The right-hand side of the x-axis is positive infinity. The left-hand side is negative infinity. The top part of the y-axis is positive infinity. The bottom part down here is negative infinity. So here's where we need this. This is what the notation looks like when we do end behavior. We're going to fill in this blank right here. So it says the left side of the graph goes down. So see how this left side goes down? So we would say the end behavior goes to negative infinity. So let me explain like what this notation says. How we say this in words, we would say as x, this arrow, we say approaches . So as x approaches negative infinity, what that means as x approaches negative infinity is basically as we go left. So this whole thing, as x approaches negative infinity, means the left. So as the graph moves to the left, approaching negative infinity, where is f of x? F of x is really like y. So is it pointing up or down, basically? So as we move left, the graph is pointing down. So it's going down to negative infinity. So to fill in this blank, we would write negative, let me do it with the pen. We would put negative infinity. So again, let me explain what this means. As x goes left, as x approaches negative infinity, y is pointing down. So as we go left, it's going down. So as we go to negative infinity on the left, y is also going to negative infinity. On the right-hand side, so as x approaches positive infinity, so this is as we go right, what is y doing? So as this graph moves to the right towards positive infinity, do we see how it's going up? So going up means we're going to positive infinity. So to fill in this blank, it would just be an infinity. So this is up, down, right, left. You'll see once we do some more examples, it gets to be easier. So when you're given a graph, you just physically, like, visually look at it. As we're going to the left, is it pointing up or down? It's pointing down. As we move to the right, is it pointing up or down? It's going up. So if it's going up, it's positive infinity. If it's going down, it's negative infinity. So that's the gist of what end behavior is. We can identify end behavior by not only looking at a graph, but we can identify end behavior by looking at an equation. And so that's what this chart down here is. And we're going to do some examples. So once we do examples, it will, I think, make a lot more sense. But let me just explain what this chart is going to be really helpful for you to do a lot of your practice that you're going to do. And like, even when we have like a quiz or something, like I'll let you use this if we're in person. So when an equation has a positive leading coefficient, so let me show you what I mean, hold on. So here's an example of some polynomial equations. See how this one has a leading coefficient of -2? That's a negative leading coefficient. This one has a leading coefficient of 1, so that's a positive leading coefficient. Then remember, we learned how to identify degree. Remember, degree is the highest number, the highest exponent. This one has a degree of 2, so that's an even number. This one has a degree of 3, so it's an odd number. So that's what we mean down here, where we say odd degree versus even degree. So it has an odd degree if the degree is 1, 3, 5, 7, 9, odd numbers. It has an even degree if it's like 2, 4, 6, 8, and so on. So odd degree functions, their end behavior, what it looks like is one side always goes up and one side goes down. So see, an odd degree function with a positive leading coefficient, the right side would go up and the left side would go down. I'll fill in these blanks in a second. I just want to explain what this means. An odd degree with a negative leading coefficient, the left side would go up and the right side would go down. So odd degree functions, there's always like one goes up, one goes down. Even degree functions, they either both go up or both go down. If it's an even degree, like 2, 4, 6, or 8, but a positive leading coefficient, they both point up. If it's an even degree with a negative leading coefficient, they both go down. So this, in time, you'll probably end up memorizing it just because you'll use it so much, but I'll always let you use this chart. So let's fill in these blanks for the end behavior. So keeping in mind, again, that the left side is negative infinity, the right side is positive, up is positive, down is negative. So remember what this means. It says as x approaches negative infinity. So as we go to the left, is it pointing up or down? Do we see again how it's pointing down? So we would say this one would be negative infinity. As x approaches positive infinity, so as we move to the right, is it pointing up or down? Up to positive infinity. So if you're filling in these notes with me, fill those two things in, positive infinity, negative infinity. Let's look at an even degree with a positive leading coefficient. Again, as x approaches negative infinity, where is the graph going? Can we write it in the chat or unmute yourself? So as we go to the left on this one, is it going up or down? Where is the arrow pointing? Anyone following me here? So as I'm going left here, where is the graph pointing? Up or down? See how it's pointing up? Yes, no, maybe. So as we move left here, we're going up to positive infinity. So to fill this in, we would put positive infinity. Okay, thank you. Give me some sort of like confirmation that we're following. And then as x goes to positive infinity, which remember means as we go to the right, also going up. So these are both positive infinity. Okay. Odd degree negative leading coefficient. So if there's a negative in the front, this is what it would look like. Left would go up, right would go down. So let's fill this end behavior in. As x approaches negative infinity, so that remember means as we go left, where is this one going up? To positive infinity or negative infinity? Where is this left side pointing? To positive infinity. Good. Then as x approaches positive infinity, which remember is this way to the right. So as x goes to the right, where are we going? Positive or negative infinity as we move to the right? Basically, is it pointing up or down? What do we think? So as we go to the right, where is the arrow pointing? To negative. Thank you, Isabella. Thank you, Noah. So it's pointing down to negative infinity. So to fill this in, it would be negative infinity. So if it's pointing up, it's positive. It's pointing down, it's negative. Okay, last one to fill in this chart, and then we'll do some examples. So an even degree with a negative leading coefficient, this is what the end behavior of the graphs would look like. They would both point down. So as x approaches negative infinity, so as we go to the left, we're going down to negative infinity. As x approaches right, we're going down to negative infinity. So that one's both negative. Okay, so if you are filling this in with me, take a second, make sure you fill that in. If you don't have a printer and you're not writing this down, I'm going to post this as soon as I'm done, and you don't need to reference it probably very often. So I'll put it right on the post from today. Okay, we ready for some examples? I'll keep referencing this when we do the examples. So first we're going to do some examples with just an equation, given an equation. So in order to use an equation to identify end behavior, we have to identify the leading coefficient. Really, you just need the sign of the leading coefficient. And for the degree, you just need to know, is it even or odd? So you don't even really need to like say what it is. That's okay, Lucas. Thanks for coming. I'm glad you made it. You missed a little bit, but maybe you'll catch on here, or otherwise we can help you after. So the sign of the leading coefficient here, this is the leading coefficient, right? This is in standard form. Remember, standard form goes highest degree to lowest degree. So this is a negative leading coefficient. So you can just put a negative sign. You don't have to actually write that it's negative too. And then the degree, remember the degree is the highest exponent. The highest exponent here is 2. 2 is an even number. So we would say it's an even degree. So then you look at your chart. We have a negative leading coefficient with an even degree. So I just like to see where it's going to point. So negative leading coefficient, even degree, looks like this. See, even, negative. So they both point down. So what I like to do is next to the problem, I like to just show that they're both pointing down. Then to answer these questions, as we move to the left, as x approaches negative infinity, where is it going? It's pointing down. So f of x would approach negative infinity. Whoa, that was a weird infinity symbol. And then as x approaches positive infinity, as we move to the right, we also are going down. So also negative infinity. So you have to first identify the sign of the leading coefficient, and then whether the degree is even or odd, then use the chart to help you figure out what it looks like. Okay, number 2, the leading coefficient is a +1, so that's a positive leading coefficient. The degree, we have 3, 2, 1. The degree is 3. That's the highest one. 3 is an odd number. So now we have odd, positive. So go to your chart. Odd, positive, the right side goes up and the left side goes down. So then I like to just write in the box. Right side goes up, left side goes down. And now we can do the end behavior. So as x approaches negative infinity, so as the graph goes to the left, it's going to point down to negative infinity. As x goes to the right to positive infinity, it's going up to positive infinity. So that's how you would do it if you have an equation. So on your practice for today, some of them are equations. I don't know how many. I think I just asked you to do the odds. Hold on, let me see. So on your practice, there are 3 examples where you're just given an equation. So you do this exact thing. Identify the leading coefficient, whether it's positive or negative, and then even or odd degree. Then there are 4 where you're given a graph. 5 where you're given a graph. Okay, so now I'm going to do a couple examples here. So this one I had positive, negative, increasing, decreasing, turning points, all of that. I'm first just going to do the end behavior part. So I'm going to do that one and this one. And then we can come back and we'll do the intervals for one of these. So this top part is what we did before vacation. So this is kind of like putting it all together. So let's look at the end behavior here. These are supposed to have arrows. This one I didn't like put the stuff for you. So it's supposed to be as x approaches negative infinity, f of x approaches, and then we fill in the blank. So we have to write that out. So as x approaches negative infinity, as we are moving to the left, do we see how we're going to negative infinity? We're going down. So that's the first part of the end behavior. As x approaches negative infinity, f of x approaches negative infinity. Now we have to do the right side of the graph. So as x approaches positive infinity, so as we move to the right, f of x goes up. So that's to positive infinity. Okay, I guess I'll do the intervals for all of these too, because I think there's maybe 1 or 2 examples on your practice for today where I think one where I have you fill in all of these. So let's recap that. Remember, a graph is positive when it's above the x-axis. Do we see how it's above the x-axis in this part and this part? Let's see if one of you can tell me this interval here. This is -2. And this is 0. How would we write that interval? If I wanted to explain, if I wanted to say that from here to here, it's positive. Can we write it in the chat if we know how to write it? Anyone remember? No? Okay, I'll do this one. Maybe someone, oh, I forgot how. Okay, thanks for letting me know. So if I wanted to say that it's positive from here to here, that's from -2 to 0. So you use the x value. So from here at -2 to here at 0, the graph is above the x-axis. So you would just write this, -2, 0. Then it's also positive from here, from +2 all the way to positive infinity. So we would say from 2 to positive infinity, like that. Then, yep, good. So then it's negative, let me get another color pen, when it's below the x-axis. So this is all negative, this is all negative. I don't know why I just wrote on this in pen. I was just thinking for increasing, decreasing, but it's not going to apply, but that's okay. So this is negative infinity. So it's below the x-axis from negative infinity to -2. So from all the way to the left to here is where it's below the x-axis. So we would say negative infinity to -2. Okay, so can someone tell me this part that's negative? What's this interval? How would we explain this interval here? Because that's below the x-axis. So that's negative. How would we write the interval? Zero, 2. Good, Isabella. So from 0 to 2. Nice, Noah. So Isabella and Noah have answered a few questions. I hope that everyone else, if you're confused or you have a question, that you let us know. If you need me to clarify anything, just ask. You could even just send it privately in the chat to just me, and I don't even have to say who asked it. I'll just say someone asked this question. All right. Next is increasing, decreasing. Increasing is when you look at it from left to right and it goes up. So if I put my pencil on the left side of the graph and trace it, see how I'm going up right now? And then here at this turning point, it switches directions and it starts to go down till here. So this whole thing is increasing because it's going up from left to right. So you would say that it's increasing from negative infinity and then it stops increasing here at 1. Then it decreases, oh, -1, just kidding. Then it decreases from -1 to +1. This is all decreasing. See how it's going down? So we would say decreasing from -1 to 1 like that. Then at +1, it starts increasing again to infinity. So we would go back to increasing and say 1 to infinity. Okay, the turning points are just the spots where they switch direction. So here and here. So that's going to be -1, 2. These are ordered pairs, and 1, -2. And then relative maximums or minimums are the turning points. This one's a max because it's a high point. This one's a min because it's a low point. So maximum is -1, 2. Minimum is 1, -2. So it's a lot. I get it. Like, there's a lot going on here, but you guys just need to ask us if you don't know what to do. So we've now been doing this top part. We did it for 3 days before vacation, and I get that that was a long time ago, but if we are still confused, you have to do something about it. You have to let us know. All right, let's just do, for the bottom one, let's just do end behavior because this is now going on for a while. So let's just do the end behavior for this one, and then I'll let you guys try the practice. So for this one, end behavior, think about as we move to the left, where is the graph going? Someone want to say in the chat. So as x approaches -infinity, where is y going? To positive or negative infinity as we move to the left? What do we think? So I'll fill it in as x approaches -infinity. F of x approaches what? Positive or negative infinity. Good, guys. So negative infinity. How about as x approaches positive infinity, where is y going? So as we move to the right now, see my pencil's pointing to the right. As we go to the right, where are we going? Negative infinity again. Good. So that's end behavior. That's really the focus of what I want the focus of today to be. This other part, positive, negative, increasing, all that, that's a review. So, you know, if you still have questions about that, make sure you ask us today, or there's ACT Lab today and tomorrow, remember. Okay, so what you are doing